Yeah, no. Okay, have your seat. We are just starting the talk about Clojure. Okay. Okay, let's start. Let's start the talk about Clojure, which is a functional programming language that runs at another language, because there are plenty of languages atop JVM, and I'm pretty sure you are pretty confident in Java and want to try another language like Clojure. So I'm here to show you Clojure because I believe functional programming languages are something you should know before judge if Java is the language for the next project or projects. So I spent a couple of, well, weeks or probably years learning functional programming, and Clojure was the language I used for my first encounter to functional programming. I also tried to grasp how to program functionally in Scala and F#, which is Microsoft functional language for .NET platform. And it took me a while to understand the merits of using functional programming language like Clojure for Java development. But once it clicked, it was pretty simple, and I hope you will enjoy it. Okay, so I'm Jacek Laskowski. I came here from Poland. I live in Warsaw. So if you've got some problems with my English, you can ask me to speak Polish, because I understand, you will understand pretty easily my Polish. Okay, so let's give it a try. Wait a moment. I completely forgot Polish. No dobrze, to spróbujmy. Więc będę Wam przedstawiał Clojure, język programowania, funkcyjny język programowania. Programujecie prawdopodobnie w języku Java i wielu z Was prawdopodobnie rozumie również język polski. Da? Okej, rozumiesz. Okay. To co, dalej mówić?
Nie,
Angielski or Polish? English. Okay. Więc będzie angielski. Hello, здравствуйте. Have a seat. Okay. So and it's been a while since I learned Russian, and it was when I was in primary school. So after 8 years, I should have known Russian better, but then you know things changed, and I had not learned more, so I stopped it and paid more attention to German and English. But then I learned Clojure. So as you see, you probably know a lot of languages, although you don't know about it. So you know English. Okay. You might not be so confident as speaking Java and then speaking English, but then still, learning languages is in the contract of any IT person. Okay, so I'm Jacek Laskowski, and I'm here to talk about Clojure as the language, a functional language on JVM. I work for Worldwide Web Sphere competitive migration team at IBM Poland, and so I'm responsible for migrating customers to our own application server. But then I'm gonna speak about Tommy in a couple of minutes. Well, minutes, quarters. Okay, so Clojure REPL. That's the environment you should be aware of before you start with playing with Clojure. And before I start with Clojure, how many of you have already played with Clojure? Oh, quite a few people. Okay, good. Was it something more than repling? What about you? Repling means, have you code something outside read eval print loop environment? Oh, you just try it. Okay, what about other people? What about you?
Only JavaScript processor.
Ah, okay, so Clojure script. Very simple. No.
Very simple processor from Clojure to JavaScript.
JavaScript. Okay. You're aware of Clojure script, aren't you?
No.
No. Okay, there is a Clojure script to develop JavaScript-like web apps in Clojure. As you see, it's pretty easy. What about other people? Did you develop any full projects? No. Okay, so it was just for fun, right? Okay, good. Good of you. So REPL, what is REPL? REPL read eval print loop is the runtime environment for Clojure for beginners. So if you start playing with Clojure, you should or you will use REPL. So REPL is interactive development environment. We got used to use IDEs for our Java development, and IDEs stand for integrated development environment, while IDE in context of Clojure is just interactive development environment, which means you just execute a form or as expression. Everything in Clojure is an expression, which means it's not a statement. The difference is huge. A statement is something you can execute, okay, but a statement does not have to return a value. Can you think of any Java statements?
If.
Sorry?
If.
If. Yeah, what about, what else?
Increment.
Increment, no.
For.
Yeah, if for loops. They are examples of statements. What about expressions in Java? Increment, plus plus. There is something I need to point out before I start with Clojure. What happens when you use plus plus, which means I plus plus while I is an integer? What will happen?
Side effect, state mutation.
Yeah, it's just an abbreviation to assign a value, a new value, to the same, well, piece of memory. So you mutate your variable, and that's the difference between Java and Clojure. You are not able to mutate your structures, data structures, whatever they are. So all you need to do is to create another one. Think about it. So if you increment an integer, you will effectively create another one. If you add an element to a list, you will create another list. Think about it. Think about garbage collection and other stuff, memory consumption. Well, you don't have to worry about it, because there are algorithms that share structures after they change. So you don't have to worry about it, but then you will have to think about it, because what you've created is not what you've got in your hands after you change it. Okay, so let me start with a simple REPL session. Okay, so what I'm gonna do is to show you what it takes to play in Clojure REPL. Okay, and okay. Can you see it? No. Okay. What about this? So line 2. Can you see it? Well, almost. Okay. So what it takes to program in Clojure? You need to have a compiler. Once the compiler is on your computer, you can compile your script, your Clojure scripts, to a bytecode. Because Clojure is, under the covers, a bytecode, Java bytecode. So that's the main principle behind Clojure, just to be as close to Java as possible, plus, giving you some functional flavor. So all I'm gonna do is to develop some applications, but these expressions, as expressions, are not evaluated. They are compiled, or they will be compiled and executed, as if you were created a program in Java. Because at the end of your Clojure programming, you will have classes compiled to a bytecode you can use from any Java application. Because after all, Clojure will produce a bytecode. So, for some, I haven't heard much about it, but for me, Clojure, Scala, Rhino, are just bytecode generators. You just generate a bytecode using different style, different language. That's it. So if you program in Scala or in Java, what you will effectively do is to produce a bytecode, right? So if you are keen enough, or if you are skilled enough to learn bytecode, you can write your Java applications in bytecode, just as you would develop your applications in assembler. So Java programming language, Scala programming language, Clojure programming language, Rhino, and any Java-based or JVM-based language is just to produce bytecode. That's it. But the difference in Clojure is that whatever you create is compiled and executed. So it aims to be as fast as your Java programs. Okay, it's not as fast as Java in many cases, but you often don't care about the differences between Clojure and Java execution times. Okay, so let me show some data structures in Clojure. Since Clojure is a kind of a Lisp, you may expect a lot of parentheses. Well, and they might kill you at first, but there is a huge benefit of using this parentheses, because they unify your format, your programming style. Well, style no, your programming application, your programming. Okay, so what it is? It's just yeah, it's an expression. Yeah, well, it's an expression. And it will return a list, an empty list. Okay, you know it. This is just a list. Okay, but in Clojure, the first element on this list is always a function. So, may I execute 1 plus other arguments? Probably not. That's true. Because 1 is not a function. 1 is just a primitive. So 1 cannot be called as a function. Okay, so what can I do? Is just to use this tick that will, make this list a list. Okay, that's it. Okay, so what about an array? Another collection. That's simple. Okay, you know it. And what I always will return is that I type something and I will return, will get an expression, a value of executing this expression. That's the interactive development, because whatever I type is already executed. Okay, so let's define, let's have a look at this. I meant to say what I'm gonna do, but it's you to tell me what I did or what I've done. Okay, so okay. So my question to you is, do you understand it? Yeah, that's that easy. In functional programming, the main building block is a function. So all you do in Clojure is to create functions, and then you will combine functions to create another functions. That's it. That's all about programming in any functional programming language, and Clojure including. There is a difference between Clojure and Java. Java is an object-oriented programming language. So what's the main building block in Java? Oh, no, not an object. Class. A class. A class is just a stamp to create an instances of itself. So you create objects. And then you combine objects to create more complex objects. Or you create a class and then use inheritance and other means of extending, this base class. In Clojure, all you have to do is to learn how to create a function. Okay, that's it. You understand it. I'm pretty sure you do. Because defn is a kind of a function. It's a macro, but it's a function to create a function called myFun plus that accepts arguments and does something. That's the body. All you need to understand is just to understand what the first element of this list does. So if you understand it, you will understand Clojure. So, and my question to you, is this a list? Yes, it is. But since this list contains some elements, the first one is assumed to be a function. That's it. Is this an array? Yes. But this defn macro or defn function will pick it as an array to distinguish arguments for this function. For this myFun. Okay, let's see what myFun is. So myFun is just like this. It's a var. Var means VAR. So var is one of the 4 building blocks for concurrency development in Clojure, which means you can change it on the fly. But they are constrained by some Clojure rules, which means that you are supposed to change it, but only because that's the data structure to be able to change an identity to another memory region and point to another definition of the function. Well, it might be confusing, especially trying to explain it when I'm myself, or I myself doesn't understand it fully. But then it's just myFun. So let's execute it. So if you want to execute it, okay, that's it. Well, I've got a wrong number of arguments because this function accepts some arguments. So myFun. So I executed this function, and the return value was 1 or nil. Why did I get nil and plus 1? Because 1 was printed by println function, while nil is the return value. Because remember, all forms, no, not all S expressions are executable, meaning these expressions return value. Okay, and then the 3 main functions of any functional programming language are map, reduce, and filter. So what does map do? I can read about it just right away. But then, who can understand? Who understood map? Wow, more than people who program in Clojure. So I assume you program in Haskell or Scala. Scala, okay. So if you understood Scala, you should not expect troubles learning Clojure, because Scala is very twisted. So the type system in Scala is well, it might kill you very easily, while learning Clojure is so simple because there are many parentheses, and that's it. Because
There are no monads.
no monads were. In Clojure, look for Clojure plus monads, and you will get many of them. State monads, and well, any monad you may find in Haskell is available in Clojure. It's not. So there was a question about monads, because he meant to scare me, but I was keen to learn monads and spend quite a few moments with monads and Clojure. But okay. Okay, so what is map? Map is a function that accepts a collection plus function to be applied to every element of this collection. That's that simple, right? For me, it's simple, but I remember my days when I tried to grasp the concept and I couldn't. It was like, I can program in Java, but I don't understand math. And I'm pretty sure many of you who've already grasped the concept spent quite a few moments to grasp this concept, because it's not that obvious for imperative programmers. It's not that obvious. So let's create a list. I created a list called LST. So this LST, how much time do I have? Because I spent lots of time explaining.
Yes, 30 minutes.
Okay, so just to show this example, and I'll move on to web applications and other GUI applications, what you might be doing in Java. So LST is just a range between 0 and 9. That's that simple. Okay, and you can count elements in this list. There are 10 elements, right? Okay, and you can sum them all up. Well, not this way, because there is another function called apply that will do. Apply. Okay. Apply that will do it for us.
Because now apply is function. And
Because
here
plus-
the
Because
plus
plus is
Yeah.
function.
list.
Yeah, because plus doesn't accept list, right? It accepts a variable number of arguments and can add them. Okay, and that was easy. What about this? What's the return of this? Could you
Zero.
Name.
No, new name plus.
Okay, who is for nil? Wow, quite a few people. Okay, who is for 0? Okay, so it's so the same number of people. So what about others? Yeah. Sorry? It's a function. Yeah, that's true. But it's a function execution.
Reference to a plus.
No. Okay, so four answers for such a simple call.
Yeah.
0. Why? Because 0 is the neutralny element grupy zadawania. Okay. Would you say it in Ukrainian as well?
Just say.
Neutral, okay. So, więc co będzie wynikiem tego?
1.
1. Dlaczego? Adin. Warum?
Because it's neutral multiplication.
Yeah, that's the default. Okay, that's how Clojure or Clojure designers meant to design this language. They thought about what you might might expect from calling this, and now you can add. Okay. What's gonna be the result of calling this function? 0. Yeah, because the the 0 at the beginning. So you already know, you've already grasped what it is to program in Clojure. So you just create functions with defn and specify the name, arguments. This ampersand means you may or may not provide arguments. So you just sorry?
Varar?
Yeah, varargs. And now comes the body. So you can call any function you want. So let's count how many arguments we pass to args. No, args to this function. Sorry, for the name is the function. So the name is the function. So let's call it. So how would you call a function in Clojure? You just start with the opening parentheses, and in REPL you can tap it, and it's gonna be expanded. 0. What about 3? What about 6? That's that simple. Well, you will have to get used to the format of how to, or the way to program in Clojure, but after a while you will easily understand what's going on. Because since you understood Java programming language, where there are many such forms, and anonymous functions, what is the generics, and how to apply. That's my question to you. Let's assume I'm in Java environment. Can you tell me what would be the return value of this? Nobody will tell you the answer. And I'm not sure if it's correct. But I'm pretty sure your mind got twisted.
Yes, it's not correct.
It's not correct, it's true. Have you heard it?
Yes.
Yeah, I know, you've heard. But all you have to do is to think about the order of applying functions or methods or how it's called. They are not functions. Operators. And you will have to eventually put some parentheses to differentiate between this or this or this. So now the funny part of Java is to understand the operator order when it's in one line. So what are Java programmers doing when seeing this line? They'll put parentheses because they can't understand what they've been doing for ages in Java with these simple operators. So of course it won't work in Clojure, but in Clojure you would do like this, provided this function exists. So 1 and like this. So all you do is to combine lists inside lists. And the first element is a function. That's it. That's the only syntax you'll have to learn. Okay, there are more, intricacies of programming in Clojure, but in its basic form, Clojure is just like this. So there are no functions like this, but let's define it. So it won't do much. And what about this? It won't do this. The wrong number of args too, because which one is a ampersand? Ampersand. Okay, let's call ampersand. Okay, it's nil. What about 2? Wrong number of arguments because I put this here. Okay, so now, as you may see, number of arguments passed to LT. Okay, LT was wrong. So what I'm doing? So okay, now it should be.
No,
Why?
because you fixed ampersand again and not LT.
Oh really? Okay, that's good. Okay, so as you can see, I can define my own operators just for my pleasure. Okay, for fun. Okay, so what about map? Map is just that simple. Apply a function. Let's call println to a list of 3 elements. What it will do is just to println every element, but then return. So it's not good function. So what about increment? So what happens here is to apply function to inc to each element and return the same data structure as you passed to this map. Actually, it's transformed to list. So it's gonna be 2, 3, 4. Okay. So what about reduce? I'm pretty sure some of you understand reduce. So what's the okay? What's the answer?
55.
55. How did you calculate it?
Because I know that sum of numbers from 0 to
10
to 10 is 55.
Okay, yeah. Gauss was the guy to create the Gauss was really brilliant guy, and in his primary school he was assigned a task to calculate the sum of 0 to 100. So he invented he reversed the serial and apply every element and divide it by 2. That's the answer. So okay, so reduce. What does reduce do? It accepts 2 elements of a structure and applies this function. So what are the first elements of range? 0 and 1. So plus 0 and 1 is 1. Then this return value is the first element of the next pair plus next element of range. So we reduce the call, because otherwise in Java you would have to do like this. Plus, plus, plus,
Yeah.
and then, well, 0, 1, 2, 3. Okay. So some of you might know about folding, right and left fold. So it's about right or left fold. Is it right? Sorry? Left. Yeah. Because we go from left to right. Because we are interested in this first, then this one and this one. Okay. That's the only fault in Clojure. But you can create another one if you want. Actually, there's okay. Anyway, so this is 6. Okay, that's the same for range 4 because it's exclusive. Alright, yeah. Well, okay. Okay, so that's it. And there is another function called filter. It's another function, so you know how to use it. If you don't, just execute doc filter and you will know. So what filter expects is to get predicate, so a function that accepts a single argument and returns a Boolean value, so predicate on a collection. And if this predicate returns true, this element will get returned. So let's assume we have So let's assume we have a function. What function shall I create?
Predicate?
Sorry?
We
Predicate?
have to create predicates.
You. Yep. Done. What about odd? What about even? Even.
What about prime?
Sorry?
What about prime?
No prime, no. Okay, so not this time. So no prime time. And so what can I do with this odd function is to apply it to I. And I'll get this function, this elements, because they are odd. That's odd. Okay, so let's finish it, because I'm pretty sure you got bored a little bit with this. So bye for now. Okay, and so let's get back to the. Okay, I can stay here. Okay, so you saw what it is to play with REPL. That's how people familiar with Ruby or JavaScript or any dynamic language is used to use, because REPL is just to read, eval, print, loop, and every expression is compiled, and then the function is the result is executed. Okay, so I show you REPL. Okay, so Leiningen. What's Leiningen? Leiningen is Maven or Gradle or SBT or whatever tool you use for project automation. So Lane is just I used to call it Maven, because I got used to working with Maven and well, in some sort. So this is just a project automation or management tool. So all you need to do to use Lane is to download a binary, a script. Type Lane2. Okay, it's Lane2, because Lane2 is much better for me. It's fresher. Okay, so what I'm gonna do is to create a Leiningen project, or create a project that's written in Clojure and managed by Leiningen. So I start with Lane2, new, and I can create an app called Hello Kyiv. So I create this. Yeah, I know. So try again. Why? Because this is my first time I use this camel case naming for Clojure project, and I should do it like this. That's the convention. Well, another language, another conventions. So Hello Kyiv is the name of my project. Okay, so let's go to this Hello Kyiv project and execute it. So Lane2, run. Okay, I run it. What can you expect from such a simple project? Just hello world. So that's that simple. Because otherwise people would have had to create some in Clojure, develop something in Clojure just to show it. So people responsible for Clojure did it for you. So I can compile it. So I can I can compile it. Install. What it will do is to create a package with my classes compiled to a bytecode. So before I show you compile, I should have done this, IBA-jar. Especially the IBA. They didn't know what IBA means in our region. So IBA-jar is just to execute our programs like this. hello Kyiv snapshot standalone. Hello world. And then, that's the point of my presentation. Since you've got Java, can you do anything you want with it in your Java projects? Yes, because this is just a job. Nobody will know if you designed this program in Java, in Clojure, in Scala, whatever language you might be familiar with, and you want to introduce it to a project. You just distribute a job. Okay, and then there are some other stuff I might be willing to show, but then I'm not. Okay, so Leiningen is just to automate your project. So there is some scenarios I was supposed to show it, but then okay I just did it very quickly. So how about developing a GUI application? Can you do it in Java? Well, I'm pretty sure you do. Or you might be using JavaDoc to understand, JFrame or JButton or whatever class you want to use. In Clojure, it's so simple like this. Len2 REPL. Okay, let's go outside this project, not to confuse the. So Len2 REPL. What it will do is to fire off the REPL for your interactive development environment. Okay, got it. Now, you want to import Javax Swing JFrame. You know it. Okay. So, JFrame is already imported. May I use it? Well, yeah, sure. Why not? So, JFrame dot is exactly like calling a function called JFrame dot, but this function call is transformed to calling a constructor of JFrame. Yeah. So I can create, so this is just one way, but for people who are accustomed to Java way, you can just do new JFrame, but as you might have noticed or might have guessed, new is a function that do whatever it should do. It's just a function. Call it new, call it create, call it whatever. So don't use it like this, because developing Clojure applications, uses some idiomatic code. Idiomatic Clojure code is like this. So just title. And that's it. I created an object. And what Clojure did for me is to print out all the attributes of this project, of this object. So, well, do you understand layout in Java? Yeah, I'm pretty sure you do. So, there are some dimensions, some locations, coordinates, and stuff like this. It all got printed. So I should have rather assign this to my val, to my constant, and execute it wherever I might need it. So I may use SetSize f and 100 100. Okay, got it. And be careful when you play with Java or Clojure Java interoperability. You should expect some mutations happening under the cover. So I just mutated the object I had called f. So from now on, this f is 100 100 in size. So if I want to show it, yeah, it's just like this, right? I might be mistaken. Hope not. Okay. And is this okay? Yeah, I got it. Now, okay, I turn off mirroring just to show you something really cool. Okay, let me do this like this. So that's mind-boggling, really. Okay, Some people know what I'm after. So, what about this? Gone. What about this? True. Right. True. Okay, I created my app. What about JButton? Java swing JButton.
You hiding the source code special?
Sorry?
We don't see.
Sorry. Turn on mirror. Turn on mirroring? Okay, sorry. So, this is the application. That's my Clojure repo. So now, I can import JButton just to add it to my, so add, okay, and JButton, click me, and add it to F. Okay. Yeah, is this like this? And pack F. Yeah, I got it. So, just to summarize what I showed you. This is the app. I created it very interactively. And I'm pretty sure you wouldn't be able to do it in Java. So although Clojure might not be the language you should use for your project, for your next project, I'm pretty sure you might be useful to explore Java API. So, aside the syntax, Clojure syntax. So, this add function, you are familiar from Java. That's the first element of this list to have it called and to have something valuable for this F val. So I created this simple app just in a couple of keystrokes, but think about it. How much time would it take in Java, in your IDE? Well, you would have to start your IDE, create a project, create a main, create another class, instantiate this class in your main, and execute this class with main function, this main method. Well, it's easy, but you know what you're doing. Think about people who are newcomers to Java. How painful for them is to learn all the easy stuff you already understood. It's not that easy for people who are new. So, if they are new, that might be a chance they might like Clojure or any functional programming language because the syntax is pretty much simple because it's all about nesting lists and stuff like this. Okay, that's all. I meant to show something more, but then I'm free to discuss more details during the breaks. So if you are keen to learn more, just ping me or just meet me outside, and I'm happy to explain more. Okay, so thank you for your attention, and I invite you for another talk about Java EE web profiles specification as implemented.